Now we want to summarize what we've done with rational functions and all the different work that we might do with a rational function. So we're going to look at finding the domain, vertical asymptotes and holes in the graph. We also want to identify any horizontal or oblique asymptotes. Decide in part D whether your graph crosses the horizontal or oblique asymptote. Remember, the graph for rational functions will never cross vertical asymptotes, but we can check in part D if it'll cross a horizontal or oblique asymptote. We want to find some intercepts just to give us a few points, and then look at the graph. So we want to go through these 6 steps to try to examine the graph of a rational function. Okay. So let's take a look at this first example. So we have f of x equal to x plus 1 over 2x squared plus 5x minus 3. Okay. Often I will put this into factor form if possible, right at the beginning. So the denominator does factor. 2x squared becomes 2x and x. And then to get 5x middle term, I'm going to do a plus 3 over here and a minus 1. Okay, and just double check that that is the correct factoring. The advantages, this helps me do part A. So in part A, the domain, remember for rational functions we need to know when the denominator is 0 and throw those numbers out. So in our case, x cannot be a half or negative 3. 1/2 or negative 3 will make the denominator 0. Part B, we're looking for any vertical asymptotes or holes. And what you want to remember for rational functions, okay, vertical asymptotes or holes would only occur at values not in the domain. So we've finished A. These are the 2 places we check for vertical asymptotes or holes. Okay. And again, keep in mind we need the reduced form of our function. Okay. Now usually when I do a reduced form, I might call it f tilde of x. In our case, it does not reduce, so our original one is in reduced form. So again, in this reduced form now, anything that makes your denominator 0 will in fact be a vertical asymptote. So nothing has changed, so we have a vertical asymptote at a half and a vertical asymptote at x equal to negative 3. Part C, we're looking for a horizontal or oblique asymptote. Or for rational function, it might have a horizontal, it might have an oblique, it might have neither though. Okay, but it can't have both. It's one or the other. Okay. And then we need to look at the degrees of the numerator and denominator. So we have the degree of the numerator that we have to compare to the degree of the denominator. Okay. In our case, the degree of the numerator is 1. Degree of the denominator is 2. That means the degree of the numerator is less than the degree of the denominator. And you want to remember then that the y equal to 0 will be your horizontal asymptote. Okay. Again, keep in mind that simply means in the long run, as x's approach negative infinity or x's become very large towards infinity, the graph, the outputs will collapse towards 0. Because in the long run, the denominator, because it's being squared, grows much faster than the numerator. So in the long run for this fraction, the fraction collapses towards 0 because the denominator becomes much bigger than the numerator. Okay, so the ends will head towards 0, the left end and the right end. Okay. Now because we do have an asymptote, it's just an interesting question to find out if the graph crosses this asymptote. So does the graph cross the horizontal asymptote y equal to 0. Okay. Well, remember, we just need to solve. We set our function equal to 0, since that's what our asymptote is. Okay. So we have x plus 1 over 2x minus 1x plus 3 equal to 0. Fraction is only 0 when the numerator is 0, and so x equal to negative 1. Okay. So at this point, negative 1, comma, 0, remember your output is 0, that's where the graph crosses the horizontal asymptote. Okay. And then one more piece of information that gives us a few points. our intercepts. Okay, so we have x-intercepts and y-intercepts. So x-intercepts, remember they take the form some x value comma 0. Okay. So remember to find these, you have to solve f of x equal to 0. Okay, now we just did that in the previous one. We were lucky because that happened to be our asymptote. So we know -1, 0 is where we cross the x-axis. For the y-intercept, remember if it's on the y-axis, the point has the form 0 comma something. So we just need to evaluate f at 0. If you plug in 0, the numerator becomes 1, the denominator becomes -3, or -1/3. So now we'll take all this information and put it into a graph. So again, we started out with our vertical asymptotes. So we have one at 1/2 and the other at -3. We also have a horizontal asymptote at 0. Now keep in mind that won't coincide with our x-axis. Remember, vertical asymptotes and horizontal asymptotes are guidelines for your graph. So it gives you an idea about where the graph is approaching. Okay. We did cross the asymptote at -1, 0. So we have this point. We also had the y-intercept at 0, comma -1/3. We don't have a lot of other information at this point, okay, but we can put a few things together. So normally we look at the 3 pieces before the first asymptote, between the 2 vertical asymptotes, and then after. Okay. So left of this asymptote, there's not much over here. Well, not much can happen. Remember, you can't cross this horizontal asymptote because this is the only place you cross it. So you're either going to begin over here and go up, or begin just below the axis and go down. Okay, so if you plug in any point, maybe -4, -5, plug in that value, you do find out that it's a negative. So you have to be below the axis. And again, asymptotes are guidelines, so we have to move towards those asymptotes. Okay. Here we have a few points. Okay, so again, we can double check, but at -2, we're either going to have to be way up here at positives or way at negatives. But if you plug in -2, it turns out to be a positive. So we know we're coming down towards this, hit those 2 points. And then again, we can't go back up because we can't cross the axis again. This is the only place we cross the axis. So we just continue on down. And again, your graphs should be heading towards the asymptotes. Again, the third section over here, right of this vertical asymptote at 1/2, there's no points we have, so we just have to decide, are we a positive or are we negative? And again, plug in 2, plug in 3, plug in 4. Any of those, you'll see it's positive. So we want to be up here, and then we finish just above the axis. And then we get a pretty decent graph for our rational function.